Could we turn the red planet into a world humans can live on? Mars, a planet of rust-colored plains, icy poles and endless horizons. For centuries it has captured our imagination. But could we truly transform this cold, barren world into something habitable? Mars is considered the most promising candidate for terraforming in our solar system. Its proximity to Earth, a day just over 24 hours long, and evidence of water ice beneath the surface make it uniquely suitable. Unlike Venus or the gas giants, Mars lies in the so-called Goldilocks zone, where sunlight and temperatures could one day support life. Mars also shares other favourable features. Its surface gravity is about 38% of Earth's, strong enough to hold a thickened atmosphere eventually. Unlike the gas giants, Mars has solid ground, which is essential for building habitats, infrastructure and eventually ecosystems. And did you know? Mars is home to Olympus Mons, the tallest volcano in the solar system, 3 times the height of Mount Everest, a reminder of its dramatic geological past. Yet the red planet is far from friendly. Its atmosphere is less than 1% as dense as Earth's and is mostly carbon dioxide. Without a global magnetic field, Mars is exposed to cosmic rays and the solar wind, which strip particles from its atmosphere over time. Temperatures swing wildly, as low as 125 degrees C at night and up to 22 degrees C near the equator in summer. This extreme variation is due to Mars's thin atmosphere, which cannot retain heat like Earth's. Human health is also a concern. Low gravity can cause muscle atrophy, bone loss, and cardiovascular issues over long durations. Radiation exposure is another major problem. Prolonged stays without shielding would be dangerous. Any future settlement would require careful engineering to protect life. One proposed method to warm Mars is releasing greenhouse gases. Factories on Mars could produce CO2, methane, or even synthetic fluorinated gases. These gases trap infrared radiation, gradually heating the surface and potentially melting ice. Over decades, this could initiate a feedback loop. As ice melts, darker surfaces absorb more sunlight, accelerating warming, a process known as the albedo effect. Another approach involves redirecting ammonia-rich asteroids toward Mars. Ammonia would decompose into nitrogen, helping form a breathable atmosphere while also contributing to warming. At the same time, we could harness local materials to release CO2, amplifying the greenhouse effect. This is a colossal engineering challenge. The mass and velocity of incoming asteroids must be precise to avoid catastrophic impacts, a cosmic-scale balancing act. Mars' polar ice caps contain vast quantities of frozen water. As the planet warms, these caps could melt, forming rivers, lakes, and eventually seas. Over centuries, water vapor would thicken the atmosphere, contributing further to heat retention. Water would also allow photosynthetic microorganisms to survive, paving the way for plants and more complex ecosystems far in the future. Some scientists propose placing massive mirrors in orbit to reflect sunlight onto the surface, particularly at the poles. By focusing energy on ice caps or dark dust regions, these mirrors could accelerate warming. The scale is staggering. Mirrors tens of kilometers across, requiring autonomous construction and precise orbital control. But it's a bold demonstration of human ingenuity. Terraforming is not instantaneous. Early phases would involve domed or underground habitats where humans can survive while experiments refine technology. Medium-term goals might target warming specific regions or melting ice caps. Full-scale terraforming, a dense atmosphere, liquid water and surface ecosystems could take centuries or even millennia. The challenges extend beyond engineering. Costs would be astronomical, requiring international cooperation. Ethical questions abound. Do we have the right to alter an entire world? Could we destroy existing microbial life? Planetary protection is not just science, it's philosophy. Current and upcoming missions lay the groundwork. Rovers like Perseverance study soil, search for signs of past life, and analyze water ice. Orbiters like Mars Reconnaissance. Orbiter map terrain and climate. Proposed human missions will provide critical insight into resource utilization and habitat construction. Every piece of data helps us understand Mars and plan the first steps toward making it habitable. Terraforming Mars is a dream for now, but a dream rooted in real science. A once barren world could one day host lakes, greenery under domes, and thriving ecosystems. The process will require centuries of human ingenuity, patience, and respect for the planet. Our imagination, paired with technology, may one day turn the red planet from a world of rust to a new frontier for life. If you enjoyed exploring the science and possibilities of terraforming Mars, hit like and subscribe for more cosmic adventures. What do you think should be the first step in making Mars habitable? Leave your thoughts in the comments and join us as we dream about humanity's future in space.